So now I've wrapped up memory in threads using standard C memory allocations and Windows threads. I'm gonna do the timer in the file system, and then hopefully I can just in the game project I can get the main entry point of the game being called in another thread, and from this game project I can then throw in some timers, and the idea will be to basically change the clear color of the renderer, which is inside the game engine, every second or something, just to start building the foundation of how the game project is going to interact with the game engine in a multi-threaded environment. What I've got now is simple timer class. Oh, not a class, just a simple timer API. And I also added some macros to make it a bit easier to use. So I've got an initialize function at which point it calls query performance frequency and does some ticks to MS conversion based on that. So we can just do a multiply later to convert times to milliseconds. It resets the timers, and I also have a function to create a timer. It just basically returns you an empty index into this array of timers. Also, I got a start function which takes query's performance counter when it's called. It stores that in the last start variable. Then when you call timer stop, it actually calls timer accumulate, which gets the current time, works out the duration, and increments some stats on the timer, like the accumulated time, the hit count. It keeps track of the shortest and longest durations. These might be useful, they also might be unnecessary, and I could do a more lightweight version if I needed to. Reset all just sets the values to something that's gonna work for the next time around, and then get data converts the stored times into milliseconds. I like to work with milliseconds mainly for game code. Sometimes you have to go to more sort of finer level of detail with microseconds or CPU cycles, but for this timer, like kind of a higher level one, it's nice to just stick in the code. So I made these macros, and these are what makes it really like nice to use, really. You can just call timer start and end, and the start function will statically allocate an integer, so it will create the timer and get the index, and then after that we can just use this. I use the tokenized thing to concatenate the name and the timer index. The name I could turn into a string and store in the timer, but for the time being, I think I want to keep that out of there and just keep the timer system a bit smaller. I guess it would only be a pointer to a char, but I think maybe I'll do it on second thoughts. Right, so what I've done now is my timer, memory and threads APIs have been implemented with the functionality I'm going to need at the moment. They will be extended in the future. I just recolored them to indicate that they need testing, and I'm going to try and use them now, basically. So what I'm going to get going is when we get the entry point, the game project executes. Entry point comes inside the lib. The lib is going to spawn a thread using this API, which is going to have the callback of the game project. And then at that point I should have the game project running in its own thread. I can start to use the timer class, because I'm going to use the timer to accumulate a time, and every second I am going to change the D3D clear color and communicate between these two. I often use this little tool called everything. It's called search everything from Void Tools. It's quite a nice tool. It just indexes your hard drive really quickly, and it's a million times better than the Windows search. It actually works how you would want a search to work, and it doesn't take forever to find your results. So I'm just using that now to put the entry point CPP into the game solution, so I can put a breakpoint, and when I run with the newly built engine, I should be able to step through it. I got the code to compile with passing the thread function in. It's a bit tricky because Windows needs the return type to not only be dword, but it needs this WinAPI underscore std call for the return, like as the prefix to the function declaration. I can use a plain old void instead of LP void, the Windows type. So I'm not sure what other threads APIs will require, but for the thread create function I also define my own thread routine, so that should be able to resolve this, because everything will happen in the threads API, so it doesn't matter if my return code is really a D word, because I can handle it and I can expose it through a common interface through this API. Now I'm just going to run the game project and step through, and hopefully I should see the thread get spawned. Okay, the first thing is that I need to change this, the external thread, the thread start function to be compatible. So we come into the entry point inside the engine. And I think it has worked, because you can see in here we've got the main thread where the breakpoint currently is, and this game entry function worker thread has been spawned. So what we should see now is if I put a breakpoint into here, yep, it's been hit, and it's hit the assert I put in. Printf still doesn't work, but I'm going to try something now. I have noticed previously with printf, sometimes you have to print more than one thing, otherwise it doesn't flush the previous one to the console. Printf isn't working, I think maybe because I'm a Win32 app and I'm not a console app, and you have to reopen the streams, so I'll look into that, but for the time being I think this is a cool place to sign off with what's going on. I've basically got game engine spawning a thread using a thread API that was successful. I'll go on to test mutexes and semaphores when I start to get more functionality that needs it. I did test memory allocations earlier, and that was working. Global new and delete were overridden. Timer has been implemented but not tested yet, so I'll start doing this, tidy this up a bit, and then next time I'll build on what I've already got.